The Greek philosopher Aristotle developed many theories on subjects studied in the modern discipline of physics. These involved what Aristotle described as the four elements. He spoke intimately of the relation between these elements, of their dynamics, how they affected the earth, and how they were, in many cases, attracted to each other by unspecified forces. Ancient Greek philosophy, of which Aristotle was the high point, marked a fundamental turning point in the evolution of humanity and our ideas about our existence in the universe. Over the past 2,500 years, Aristotle's philosophy has directly contributed to the evolution of our current science, reason-based society. Thus, it is unfortunate that many people imagine our postmodern society to now be so enlightened that Aristotle and other ancient Greek philosophers have become irrelevant. Their knowledge remains a mystery. Natural places, each element would like to be at a different position relative to the center of the earth, which is also the center of the universe. Gravity, levity. To achieve this position, objects feel a downward or upward force. The Aristotelian theory of gravity stated that all bodies move toward their natural place. For some objects, Aristotle claimed the natural place to be the center of the earth, and thus they fall toward it. For other objects, the natural place is the heavenly spheres, and as such, gases. Steam, for example, move away from the center of the earth and toward heaven and to the moon. The speed of this motion was thought to be proportional to the mass of the object. Rectilinear motion. Motion in response to this force is in a straight line at a constant speed. Velocity-density relation. The speed is inversely proportional to the density of the medium. We'll discuss later. Vacuum is impossible. Motion in a vacuum is infinitely fast. All-pervading ether. All points in space are filled with matter. Infinite universe. Space cannot have a boundary. Continuum theory. Between atoms is vacuum, so matter cannot be atomic. Quintessence. Objects above the earth are not made of earthly matter. Hypothetically, dark energy. We'll discuss later. Incorruptible and eternal cosmos. Sun, planets are perfect spheres and do not change. Circular motion. Planets move in perfect circular motion. Elements. Aristotle believed that there were four main elements or compounds that made up the earth, air, water, and fire. He also held that all the heavens and every particle of matter in the universe was formed out of another, fifth element he called aether, also transliterated as ether, which was supposedly weightless and incorruptible. Aether was also known by the name quintessence, literally and actually fifth substance. Heavy substances such as iron and metals were primarily consisting of the element of earth, with a limited amount of matter from the other elements. Other, less heavy and or dense objects were thought to be less earthy and composed of a greater mixture of other elements. Humans were shaped with all the substances, with the exception of aether, but the relative proportion of elements was unique to each person, and there was no standard amount of each within the human body. Dynamics. Aristotle held that each of the four worldly elements would each seek each other and cluster together, and that this seeking of other similar elements would have to be hindered or to be stopped. as it was as natural as two magnets rejecting each other or rain falling from the clouds. For instance, because smoke was mainly air, it would rise to meet the air in the sky. He also taught that objects and matter could only move so long as a form of energy was forcing it in each direction. Therefore, if all the applied forces on Earth were removed, such as the throwing of a rock, then nothing could move. This idea had flaws that were visible even at the time the concept was formulated. Many people question how an object such as an arrow could continue to move forward as it had left the power released by the string and continue to sail forward. Aristotle proposed an idea that arrows, etc., created a type of vacuum behind them that forced them forward, which was consistent with his interpretation of motion as an interaction of the moving object and the medium through which it moves. Since the turbulent motion of air around an arrow is very complicated and still not fully understood, any discrepancy with observation could be swept under the rug. Because Aristotle placed the medium at the center of his theory of motion, he could not make sense of the notion of a void central to the atomic theory of Democritus. A void is a place free of anything, and since Aristotle asserted that motion required a medium, he concluded that a void was an incomprehensible idea. Aristotle believed that the motion of an object is inversely proportional to the density of the medium. The more tenuous a medium is, the faster the motion. If an object is moving in void, Aristotle believed that it would be moving infinitely fast, so that matter would instantly fill up any void now that it formed. Because his theories appeared to make sense, they became popular and well accepted for a very long time. The key ideas that Aristotle tried to teach were: all motion on Earth is linear, all motion in the heavens, outer space, is curved. The speed at which an object falls is directly related to the mass of an object. Motion could be considered in two main contributors, natural and violent. The natural motions included the apparent movements of celestial objects, the falling of leaves to the ground, the upward movement of flames and hot gases in the atmosphere, or of air bubbles in water, and so on. According to Aristotle, the cause of such motions is that all objects and substances have a natural place or level, such as air above, water below, and they proceed in the most direct way along straight vertical paths to their natural places. The motion of the celestial bodies is circular because this is the most perfect kind of unchanging eternal motion, whereas the necessarily transitory motions of sublunary objects are rectilinear. It may not be too misleading to characterize Aristotle's concept of sublunary motion as a theory of buoyancy, since the natural place of light elements is above and the natural place of heavy elements is below. If an object is out of place, it naturally moves up or down as appropriate to reach its proper place. In addition to natural motions, Aristotle also considered violent motions, which were any motions resulting from acts of volition of living beings. Although his writings are somewhat obscure and inconsistent in this area, it seems that he believed such beings were capable of self-motion, of initiating motion in the first instance, without having been compelled to motion by some external agent. Such self-movers can induce composite motions in other objects, such as when we skip a stone on the surface of a pond. The stone's motion is compounded of a violent component imparted by our hand, and the natural component of motion compelling it toward its natural place, below the air and water. However, as always, we must be careful not to assume that this motion is to be interpreted as the causative result of the composition of two different kinds of forces. It was, for Aristotle, simply the kinematic composition of two different kinds of motion. Motion continues so long as there is only an applied motion to an object. Removing the motion stops the object. It would take a man named Galileo to start the wheels of change in this field of knowledge called physics. The solution is to realize that space is moving, that it is the motion of space, which is the second thing we can exist within the one thing. The motion is a wave motion, so we are simply saying that space is vibrating. Space is a wave medium and has waves flowing through it. We see that Aristotle's required activity is in fact a wave activity. Therefore, we see how the second existent motion exists within the one fundamental existent, space.